Let's be real. Companies hire data scientists to make more money. That's why I'm tackling a problem that demonstrates one of the ways I can help increase profit and support executives as they make business decisions in this uncertain world. Hi, my name is Chosen, and I'm a data scientist, creative director, and entrepreneur based in Vancouver. This project is a time series forecasting problem where I predict the demand for products in my father's specialty cafe in Manila. The cakes are particularly delicious, but they have the shortest shelf life of any product in the store, and they take up a lot of space. When these cakes expire before they're sold, there is food waste and the cafe suffers financial loss. So, if I can predict the demand, the company can minimize spoilage. However, forecasting human behavior is complex, and the most we can do is make educated guesses. But we can do our best. Data wrangling was the first challenge. I gathered and cleaned 300,000 data points across various data sets from 4 years. Since this is real data from a startup with no internal data infrastructure, it was pretty wild. The full data set was only accessible through the service of their POS provider due to internet server crashes. So I helped the manager request the full data set from the provider. And as if the 16-hour time difference between Manila and Vancouver wasn't enough, the IT teams of both companies were not fully operational because of COVID. This delayed the project by weeks and required me to manage the scope and timeline of my project on a tighter schedule than expected. Ideally, I actually wanted to generate recommendations for how many and when raw materials should be delivered to the store, and to calculate profit. But I had to narrow the project down and focus on just forecasting the demand for the most perishable product. The next challenge I learned to navigate was merging the data sets. It turned out that the columns I needed to merge were not an exact match, so I got to learn how to use Levenstein distance to measure the similarity between words in both data frames. In the end, I had 783 rows and 3 columns for all subcategories, and 160 rows for just cakes. I aggregated the data by week because raw materials are delivered once a week. Now, using profit to model, I predicted the number of slices of cake sold per week. The black points here are the actual sales, and the line is the forecasted demand. While there seems to be a nice balance between the points above and below the prediction, you can still choose to deviate from it as long as you stay within the shaded area. The average difference between forecasted and actual demand is 13 slices of cake per week, but this is manageable since the cakes have a 3-month lifespan anyway. And just to make it clear, this performance metric does not differentiate between the forecast being lower than the actual sales or higher. These are actually two completely different things. If the forecast is lower than the actual sales and we use it to determine how much raw materials to order, we risk losing revenue through missed sales. If the forecast is higher, then we risk products expiring. So, moving forward, I want to develop a performance metric that is designed to evaluate the model so we can see how much revenue is being lost to either missed sales or food spoilage. Second, I want to reach my end goal of recommending when and how much raw materials to order for all products. And third, I would like to use other research and modeling techniques that account for factors profit does not see. And finally, my recommendations to the cafe. Change your POS provider if you can. If not, make sure to download your data every month so when an analyst comes, you have the data ready to go. If you have the capital, please invest in data. You'll save more money and get better ROI because you'll be making data-driven decisions instead of guessing. And that's what I have so far. If you would like to learn more about this project, please reach out via LinkedIn or email. And thanks for watching.